hydrochloric acid per 500 cm of solution. B was prepared by diluting 50 cm³ of saturated solution of sodium carbonate at room temperature to 100 to 1000 cm3. After titration using methyl orange, 26.26 cm³ of A, which is the acid, neutralized with 5.00 cm³ of B, which is the base. From the formation above, calculate 1. The concentration of A in mole per dm³, B. Concentration of B in mole per dm³, III. 3. Volume of CO2 that would be liberated from 1 dm³ of B if the titrations were carried out at STP. Now, the first we need to do here is 1. Our A is our acid and our B is our what? Base. We need to understand that our A is acid and B is what? Base. The first thing we need to understand is that we're given our volume of acid, our volume of acid when we perform titration. So the volume of acid that was required for the titration to be completed was the volume of acid is equals to what? 26.26 cm3. And the volume of the base, which is a default standard, the base here was 25.00 cm³ of the what? Base. So we're given that. Well, if you look at the first sentence, it said A is a solution containing what? 1.04 grams of HCl per 500 cm³. It means that there was 1.04 grams of HCl present in 500 cm³ of solution. And as a default in chemistry, when we are talking about solutions in chemistry are prepared to 1 dm³, to 1 what? dm³ or 1000 cm³ of solution. So therefore, if 500 cm³ of solution contained 1.04 grams of HCl, it means that 1000 cm³ of solution should contain what? Since we don't know it, let it be x, because multiply. That's 500x is equals to 1000 times 1.04. So 500x is equals to what? 1040. Divide both sides by 500. So x should be giving you what? Should be giving us 2.08 grams of HCl in what? 1000 cm³ of solution. So this is the amount of HCl we have in 1000 cm³ of solution. So this is the mass concentration. This is the mass was concentration. So the mass concentration of HCl is equals to what? Is equals to what? 2.08 gram per dm³. So we have to get the what? The molar concentration. The molar concentration. So the molar concentration, which is Ca, which is molar concentration of the acid, is equal to the what? Mass concentration over molar mass of A. So what is A? HCl. So what is A? A is HCl. So what is H is 1 times how many atoms of hydrogen do we have here? 1 plus what is chlorine? 35.5 times how many atoms of chlorine do we have here? 1. So that's going to be what? 1 plus 35.5, which is 36.5 grams. Yes. So definitely, so to get our molar concentration of A, it will be the mass concentration, which is this 2.08 over 36.5, which should be equals to any value we get. We put it here. So let us look at it. How do we get the concentration of B? So that we have been able to solve question 1. Question 1 has been solved. So how do we get the concentration of B? Now, concentration of B is unknown, right? So the formula we use is Ca Va over Cb Vb is equals to Na over Nb. we have to specify what all these parameters are. So Ca is concentration of acid, which is A. Cb is concentration of base, which is B. Va is volume of acid, and Vb is volume of base. Na is mole ratio, mole number of A, and Nb is mole number of B. So concentration of A, concentration of A now is any value we have here, we put it here. Then volume of A from the question is clearly 26.26 cm3. Concentration of B is 5.00 cm3. Volume concentration of B is unknown. So Na, what is Na? So Na and Nb is gotten from chemical equation. So let us write the chemical equation for this reaction. So we have a reaction between HCl and sodium carbonate. So Na2CO3 plus HCl should be equals to sodium chloride plus water plus CO2. So balance the equation by putting 2 here and putting 2 here. So by the next class, I'm going to show you how we do get how to write a chemical equation for titration experiments, and we are going to continue in the next class. See you very soon.